Okay, so if I do, can y'all see that? If I do log 7, close the parentheses, divided by log 2. Because there is no, your calculator only does base 10, or most people's calculator. Some of you have fancy calculators, let you put the base in there. But you hit enter and it gives you the answer there. Some of you have it, I don't know. Some of you, whenever you push log, it lets you type in the base. I don't know, maybe in a cat, maybe? I don't know. What do you mean? The answer is 2.8. That's, oh, that is log base 2 of 7. So the log base 2 of 7, you do the log of this number divided by the log of this number. That's the change of base. It's a function. It's like, that's like saying, what does the, why am I drawing a blank now? That's like saying, what does the square root of a number equal? Well, it depends on the number you put in there and how it calculates. So log is an operation that happens on the number. So to find what it is, remember it's an exponent. And it tells you what that exponent would be on A here. Yeah. Well, you don't even put it up there. You would just say this equals 2.807. So. So the point of those was not really for your calculator. The point of those was more to look at it and say, okay, so 43 was f of x equals log base 4 of 2 minus x. So this was to look, this is a reflect over y and a shift left 2. So then you look at the graphs that are below, and there's 4 of them down there. Which one is shifted left 2 and reflected over y, and you're matching it to those. You won't have to graph. Well, so the base impacts it a little bit but when you're graphing, you can figure out which one it goes with just based on that. I'll only have you graphing in base 10 or natural log whenever you're graphing by hand for right now. Huh. Yes. 53. Oh, this was a good one. So it gives you this equation: log of I over 12 equals negative 0.00235x. And it says that what's the intensity at a depth of 40 feet? And my depth is represented by x. So I'm going to plug a 40 in for x. So the log of I over 12 is equal to negative 0.00235 times 40. So I get log I over 12 equals negative 0.094. Now I need to figure out, well, how am I going to solve that for I, right? I'm going to use the log properties here that says if I'm dividing, I can split it up with what? Subtraction. So I'm going to say log I minus log 12 equals negative 0.094. Does that confuse anybody? This is just a number. Log 12 is a number. There's no variable in there. You can literally hit log 12 on your calculator. There's no base indicated, so it's base 10. So log 12 is 1.079. Now what can I do? That's right. 53. So this would be 0.985. And this is touching a little bit on what we'll do today, but how do I get I by itself here? What can I do? Change the form to exponential. What's the base? 10. It's not there, but it's 10. So 10 to the 0.985. And then whatever that comes out to be. 9.66. Do you see how, though? Let me see what we did. Yes. Anything else from your homework? 54. So 54 is the exact same way. It's okay. The difference is that's an I. Yep. The only difference is this number. And then they ask you to plug in 10 here. Okay, the same steps. Anything else before we move on to equations? You do not look like you feel well. Are you sure you're okay? All right, let's move on then. Y'all right in. So we're going to talk about exponential and log equations. Let's start with exponential. Couple of things to remember. If you have something along these lines, in other words, the bases are the same, what do you know about the exponents? They have to be the same also. Those have to have the same value, right? If the bases are the same, that's going to be a really handy little tool to have in our tool belt here as we start working with some of the exponentials. So, for example, if I had 2 to the x equals 8. Y'all may, it's 3, and this is a really, really easy. We're going to do a little bit harder one in just a second. This is an easy example. But when we did this in Algebra 2, I called this base manipulation. Y'all remember that? Which basically means, can you force both bases to be the same? Because if you can, then you set the exponents equal. We don't have to have their consent. It's just writing them another way. Y'all shut up. Oh my gosh. Can we not? All right, so 2 to the x is the same thing. Here I can rewrite 8 as 2 to the third. A lot of you said, wait, we already know that that is 3, and you're absolutely right, because if the bases are the same, then the exponents must also be the same. I'll give you just a second to catch up with me before we crank it up a notch. then set the exponents equal. If you can force I'm going to show you one that's not as common in just a second. I'm going to put a little asterisk here that says the exponential term needs to be isolated first. That'll make sense in the next example. So the 2 to the x equals 8 might be an algebra 2 type problem. But since we're doing pre-cal now, I need to solve for x. Say that again now. No, because exponents come first. So this is what I mean by isolating that exponential piece. So before I even start, I'm going to get this myself first. Divide by 20. This is an example. So if I divide by 20, and keep your fractions here because it's going to make your life a lot easier. So I have 1/2 to the x over 3 equals 5 over 20 is the same thing as what? 1/4. So now I have this exponential term that equals just a single value. So I'm thinking maybe, just maybe, I could manipulate the bases to make them be the same. Do you see how I could possibly do that? Square what? So what am I doing? Yes, 1/2 squared. Am I squaring over here? No. 1/4. And I asked that for a specific reason because a lot of people will come over here and want to put a squared here and say, well, that's the same thing. Well, you can't just do what you want. You have to keep the value the same. So 1/4 I could rewrite as 1/2 to the second power. Do you agree with that? It's not changing its value. It's just writing it a different way, right? So I have 1/2 to the x over 3 equals 1/2 squared. Well, now the bases are the same. So I can ignore the bases and just set those exponents equal to each other. So now I know that x over 3 has to equal 2. It'd be 6. Everybody see what we did there? Can anybody think, whenever I got to this point, of another way besides base manipulation that maybe I could have solved that? How do I do what? Okay, I could try to graph it. How about an algebraic way? But a graphing would work. You're exactly right. What if I changed the form? Would you change the form here? To a log. You're exactly right. How did we not think of that? Both ways work. What would this look like in log form? Log, the base is 1/2 equals, if you look, I end up doing the same thing because here I'm asking myself, what exponent do I have to raise 1/2 to in order to get 1/4? 2, because 1/2 to the what power gives me 1/4. 2. So log base 1/2 of 1/4 is 2. I'm back to the exact same equation. Another way to look at it there. Everybody okay? You want to do another one? Let me give you one to try. Some ways lend themselves to the other way, but you do whichever way you like. I won't say solve it with base manipulation or solve it by logs. I'll just say solve. So you can do whichever way you're more comfortable with. Yes, you'll have a calculator. Say again? Yeah. Let's do one with an E, because you may not be able to force the same base with E. So it might force you to do a log. Well, let's do one more and then I'll do an E. Let's do, this is number 6 from your homework. Solve for X. Y'all get it? No. I see no. I see here. What do you do first? I got 5 to the negative x over 4. Oh, this one came out too easy. This one you didn't have to do any manipulation because the bases came out the same anyway, right? So negative x over 4 equals what? Does it equal 5? Oh, it equals 1. That's right. So what does x equal? Do the opposite to get rid of it. Yeah, if you look in my middle desk drawer, there's some. I know it does that sometimes. I'm sorry. In my desk drawer in the middle. No, we got to do log ones too. But I'm going to do one more example. The log is where they start log, but we're going to change them to exponential. So it's kind of the same thing. Uno más. That means one more. Base manipulation or rewriting, changing forms. This is number 16 from your homework. Yes. That's going to be the only way you're going to be able to do it because you're not going to be able to get a base of E on the other side. So everybody can get to that point, then you don't know what to do after that. Yes, because there's no way. I don't know how to make 5/3 have a base of E. Do you? No. So my only other option is going to be that alternate to base manipulation, which is change it to logs. So it's a log base E of what? Well, you might even look at that and go, but wait, I don't know what that is. But this is a calculator problem. So on your calculator, you would do natural log of 5 divided by 3. Well, because if you just type log on your calculator, it's going to be a base 10. Mm-hmm. Yep. And what do you get? 0.5108. At least 2. Mm-hmm. Questions about exponential equations? What? How do you write that with a base of E? Well, you do now. Now you do. You didn't before. But that's not an exact. You can't even get it exact because E's irrational. Okay. Logs of what? That's that. Remember, I gave you that equation with the limits. The limit is x goes to infinity of what?
Like in the real world, where they get E from.
E mostly comes up in things like Richter scale. I'm not even following y'all. I was in the process before somebody else blurted in. Lots in finance with growth and decay and your interest and things like that. E comes up a lot. E comes up whenever we start talking about logarithms and the Richter scale. You know, the Richter scale that measures that's based on a logarithmic. What? You know, Brett, you can be a real jerk sometimes. All the time? Somebody said all the time. All right. I think so. We're not going to, I'm really just hitting the highlights on this lesson, but this is the hardest. So we have some different scenarios, okay? And I'm going to run through 3 scenarios quickly, and then I will be done. We're going to look at scenario number 1 being 1 log term in the equation. So, for example, something that looks like this is an easy solve for us because with only 1 log term, it's easy to get it by itself and solve it. So the first thing I'm going to do is isolate. What does isolate mean? Get by itself. Isolate the log. If there's anything in front of it here, make sure you get rid of that before you do anything else. And then I am just going to change forms and solve. So this would be 10 to the second. And this is an easy one because if the exponents then are the same, the bases, so what does x equal? Do you understand why I would say that? Exactly, exactly. It could also be negative 10 there. What? If there's a sub available, yeah, but there's no guarantee that's where they'll be. Two log terms, same base. This one is pretty self-explanatory. It's the easiest of all of them. If I have two log terms, same base, nothing else, so maybe log base 2 of x minus 5 equals log base 2 of 10. If that's the case on either side of the equal sign like that, I can just set these arguments equal to each other. So x minus 5 equals 10. So x equals 15, right? I won't spend any longer on that. I'll just, okay. I'll just leave that there. I called them arguments. Or drop the log portion and solve. Mathematical, I know. Okay, well, whatever. You will not encounter this very often. That's why I'm not even, I just thought it worth mentioning, but scenario 3. 3. This would also work in the prior scenario. You could have done this. But what you want to do, this could look something like, remember natural log is still log. Yes. But it still holds all the log properties. What I want to do is get all the logs together on the same side before I even start. Yeah, with the numbers in front and everything. Just get everything. So the only piece I have here is this one that I'm going to move over. So I have the log, bless you, I don't know why I put that. Thank you. Any thoughts on what I do now? How can I, you're right, but how can I combine them? Whoa. Okay, that was a great guess, but that was always the answer in Algebra 2. We're going to condense what we can. Okay, so always go left to right. Here, I got a FOIL, yes. So I'm going to come off to the side here. 3x minus 2 times x minus 1 would give me 3x squared minus 6x minus 2x plus 2. So this would be the log of 3x squared. I'm already seeing that I picked a terrible example. And I'll show you why in just a second. We're going to have to use our calculator to solve. But this is going to come over. And now I can divide. No, we're not going. Well, I mean, we could, but we're going to end up in a remainder situation. We're not even going to do all that. We're just going to write it. Well, no. So now what I'm going to do, once you've condensed down to just one log, I'm going to change the form to solve. What's the base? E. What's the exponent? 0. Equals that. E to the 0 is what? 1. So what I'm looking for is I'm looking for where this equation equals 1. This is not something that I would try to solve algebraically. Currently, I would probably take out my calculator at this point and find where it equals 1. I could either find where it equals 1 by graphing this and finding the intersection. Y'all remember how to do that? Yes. Or I could make it equal 0 and find the 0. Let me just show you on my calculator real quick. Yes, Fred. I'll just use Desmos. Well, you'll end up with a remainder because it's not a factor. What do we have here? 3x squared minus 8x. Oops. Plus 2. And I am also going to graph the line y equals 1. Why is it not graphing? Where? Well, I did too, but where's my line? I don't know why it won't do. There it is. Y equals is not implied, Brett. Well, if it's just a constant, it's not. You can. Just like we have plus or minus 10 on the other. You can have 2 answers. All right. That one was a little bit harder. Let's do 1, and then I'll be done. Those are those two decimals. Let's do 1 you can solve. What? Top. If you just do the bottom in parentheses, it'll do 3x squared minus 8x and then plus 2 over x squared. All right, uno más. Didn't I already say that? Sorry. Uno más more. Clearly. I think we'll do one more. This is 37. This should put us in a quadratic situation. Because there's not x, there's only two x's. You're definitely going to need it because it's going to have e's in it. All right, let's get all the logs on the same side. So I'm going to move this one over. And start condensing. Y'all try this one. See if you can get it condensed down on your own. So let me try to get your situation. Everybody at least get here. I'm sorry. Did you at least get it condensed down to here? Oh, I'm sorry. When I get to this point, I can multiply both sides by 8. This is something you can solve without your calculator. If I move the 8 over, I end up with x squared plus x minus what? 20? That looks pretty factorable to me. What do you think? Nah? A lot of work for that problem, right? You don't think so, Ethan? I'm so happy to hear you say that. I was thinking like 32. Pushing it a little bunch. I don't know what 72 is. Those two are multiple choice. So 72 says justify the conclusion made about natural logarithmic regression in the 3 types of logarithmic re-expression box on page 293. That's what y'all want to do? That's exactly what I was doing.